Okay, so for today, or for this section, we are looking at temperature conversions. This is the last section in this unit. So we're looking at temperature conversions between Fahrenheit and Celsius, which is actually pretty useful because they do use Fahrenheit in the States. So let me just grab an actual pen. That's a prettier color. Okay, so in the US, they use the Fahrenheit scale. I remember when I was a kid, I used to see that they would report things as being like 100 degrees, and I thought that it was boiling, but it's not. So they use the, oops, I'm supposed to say Fahrenheit scale, sorry guys. They use the Fahrenheit scale, so degrees Fahrenheit, which is something from the Imperial system, and Canada, thank goodness, uses the Celsius scale, which makes much more sense, and is part of the metric system, which is where we would like to be. So in the metric system, water is going to freeze at 0 degrees Celsius, and it boils at 100 degrees Celsius, nice round numbers. Unfortunately, in the Imperial system, water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. So when they're talking about things being 100 degrees Fahrenheit, they're not actually boiling. The relationship between the two systems is based off of the fact that is based off of the two freezing points. Sorry guys, I'm just trying to slide down here. The two freezing points. So we have two formulas. There's not going to be any proportions in this section, which I'm sure you are relieved, because we've kind of proportioned ourselves out here. So solving for Celsius. Now, I'm just gonna make a note here. So solving for Celsius, right here, it says that degrees Celsius are equal to 5/9 or 5/9 times this F is where you're going to substitute in your degrees Fahrenheit. Okay, minus 32. And you'll notice there's some brackets in there, which is important because that comes into play when you're doing the actual equation. And then if you are solving for Fahrenheit, you are looking at slightly different formula. The 5/9 has been flipped, so you've got 9/5 times degrees Celsius plus 32. So there's no brackets in this, okay? And the number one thing that I've noticed students do when they're looking at these questions, if they're going to get one wrong, it's because they just picked the wrong formula. Okay, so just make sure if you're solving for Celsius, you pick the formula with the C equals, and if you're solving for Fahrenheit, you pick the formula with the F equals. So I've got a couple examples here. First example, in Seattle, so I'm going to highlight the information here. Somebody said it was 42 degrees Fahrenheit. So they're giving us Fahrenheit, we can probably assume, I'm going to just change colors here. If they're giving us Fahrenheit, we can probably assume we're looking for Celsius, okay? So I like to highlight just so that I know. Giving us, I'm going to stop writing Fahrenheit soon here. It's a weird word. Giving us Fahrenheit, and they want to know what the temperature is in degrees Celsius, okay? So we have to pick the correct formula, which would be this one, C for Celsius, that's what we're looking for, okay, is equal to, so Celsius is what we are looking for. Awesome. So C is equal to 5/9 times F minus 32. It's really important to note that we have brackets. I already mentioned there's brackets in this formula, so you have to make sure you pay attention to bed mass. And bed mass says that we have to do our brackets before we do anything else, so that's just something that we should. I feel like brackets is spelled with a CK. Apologies for any spelling mistakes. We have to do brackets though before anything else. Now, this formula I like to rewrite kind of in the same way when we were doing volume and we had 1/3 for cones. They were 1/3 the volume of a cylinder, and you're probably like, what are you talking about? But I'm just going to rewrite this formula so that it's slightly easier to do, maybe. I think it's easier to do if you look at it this way, okay? Because 5 over 9 is just 5 divided by 9, right? So what we can do is we can say there's the 5 on the top, and 5 times your degrees Fahrenheit minus 32. We can just rewrite this, divided by 9, okay? For me, this is a little easier to work with because I just don't like multiplying by fractions. But if you do like multiplying by fractions, do it either way you like. The main thing, though, is that you have brackets, and you must remember to do the brackets in your calculation, okay? So they have given us 42 degrees Fahrenheit, and I just want to double check. Okay, good. 42 degrees Fahrenheit, that's what we're going to have to substitute in, okay? So we're going to write out our formula. Okay, degrees Celsius is equal to, I'm going to do it the way I like to do it, but again, do it however you like. F minus 32 divided by 9, that's what that means, okay? Now, I know my brackets are first, so if my brackets are first, in BEDMAS, I need to do this part before all the other parts, okay? So these are my brackets, and this is what's in the brackets, okay? So we're just going to make sure that we pay attention to that. But before we do that, we need to substitute in our numbers. So 5 times the value they've given us for F, or degrees Fahrenheit, is 42 minus 32, okay? And then this whole thing divided by 9. So again, this right here is the part we need to do first. And then after that, we can do the multiplication and the division. Okay, so first, and then this part we can do second. All right, so 42 minus 32 is 10. So degrees Celsius is equal to 5 times 10 divided by 9. Now I'm doing this in a lot of steps. Please always write the formula out with no numbers, same as we did in the last module, okay? That step's really important. I want to see you substitute in the numbers, okay? So these two steps I want to see when I say show your work. Here, if you don't want to write out like this in between step, you don't necessarily have to, but I would recommend you do it just to keeping track. But anyway, so from there, we're going to do degrees Celsius is equal to 50 over 9, okay? And if we put that, that's the same as 50 divided by 9, because that's all a fraction is. So our degrees Celsius, it's not looking very nice. Let's move that to up here. So in degrees Celsius, we are looking at 50 divided by 9, which is 5.6 degrees Celsius, okay? Maybe I'll erase this because I've got degrees Celsius twice. So 5.6 degrees Celsius, that is our answer. Okay, you can go to 1 decimal place. You don't need to go to anything more, or sorry, yeah, any more than 1 decimal place is unnecessary, okay? So 1 decimal place is good. Smiley face. Evil smiley. I hate my smiley faces. They always come out, oh my gosh, looking kind of evil. Okay, let's get rid of this. Oh my gosh. Yeah, there we go. Okay, 1 decimal place is good. All right, so one more example for you guys. And, actually, yeah, one more example. So on a hot summer day, the temperature of tar heated, or sorry, on a paved road, heated to 48 degrees Celsius. I don't know why this is being a pain in the butt, but it is. Click. Okay, so 48 degrees Celsius. What is the degrees temperature? Degrees in Fahrenheit. Okay, so 48 is what we're going to be substituting in. Degrees Fahrenheit is what we're actually looking for. So we need to use the other formula. And degrees Fahrenheit is 9 over 5, right? Because that got flipped. You are always going to have access, by the way, to these formulas. Multiplied by the degrees Celsius, and this time it's plus 32. So you'll notice there's no brackets. We still have to worry about BEDMAS though, because we are going to make sure that we do division and multiplication first, and addition and subtraction second, right? The other way that you can write this formula, similar to what I did above, is you could say 9 times your degrees Celsius divided by 5 plus 32 if you want. I like it this way. Okay, that's another way you could write it out though. So substituting in 48 degrees for the value C, right? Okay. Oh, it's just like changing colors for me. That's spooky. Hello. I don't want you to be yellow. I would like you to be blue again, please. There we go. Okay, so this right here is where we're going to be putting our degrees Celsius. So Fahrenheit 9 times 48 divided by 5 plus 32. So this is what we're doing first, right? Per bed mass, we do this first, and then we add the 32 second, okay? So 9 times 48 divided by 5 is going to give us 86.4, okay? And that's going to be plus 32. So our degrees Fahrenheit are going to be equal to 118.4 degrees. Okay, and this is the correct answer. So again, make sure you show your work. There's not a lot of practice questions for this, but I will, if you look in the comment section of this video, I will have assigned some. Yeah, and that's all there is for Module 2. Okay.